So I've got it. My name's John Cox, and I'm introducing the speakers. We've got a few housekeeping things that we need to take care of, or at least make you aware of them. Turn off and set your phones to vibrate, please. Uh, please complete the session evaluations in the back after the program. CEU information is also in the back if you're applying for a CEU. Scanning badges to confirm attendance for CEUs and attendance certificates. Please make sure you have your badge scanned. Visit the show for more educational opportunities. Okay, so let me introduce the speakers. Sorry, I didn't print this, so I got to read off my daggum phone. So first is Caitlin Simpson, Tile Council of North America. Caitlin Simpson is the Director of Laboratory Services for the Tile Council of North America's Product Performance Testing Laboratory. She's also Committee Manager for the ANSI Accredited Standards Committee A108 and U.S. Technical Advisory Group for ISO TC 189, International Technical Committee for Ceramic Tile and Installation Materials. Additionally, she actively serves on various standard committees, including ASTM 21 Ceramic Tile, ASTM C18 Dimensional Stone, ASTM F13 Walkway Safety, and ASTM F515 Consumer Products. Ms. Simpson earned her degree in Ceramic and Materials Engineering from Clemson University and joined TCNA in 2006. Grant Davidson is also Tile Council of North America. Grant graduated from Clemson University in 2018 with a degree in Materials Science and Engineering, and has been a standards development engineer at the Tile Council of North America ever since. He is involved in the research, development, and revision of consensus-based standards and serves as the executive officer on ASTM Committee C21 on ceramic whitewares and related products. Grant conducts scientific research at the TCNA Product Performance Testing Laboratory, focusing on frictional properties of ceramic tile and other hard surface flooring materials, a topic of which he has presented multiple times to the international community. In addition, he conducts forensic and material characterization testing for the TCNA labs, including optical microscopy and scanning electron microscopy. Sorry, Miss.
It's okay.
That's a hard word. And welcome Caitlin and Grant.
Thank you so much. Welcome, everyone. It's good to see so many faces here at 8 o'clock on Thursday. I know that it's been a long week already. A lot of people going out every night. So good to see faces here. So go ahead and get started. Today, we'll cover a few things going on in the lab. I'll talk a little bit about our testing services and how products are tested for conformance in the industry. We'll talk about how things are reported, represented, and used throughout the industry. Learn about new and upcoming standards in our industry, and learn how new products with antimicrobial properties are evaluated. But first, press the wrong button. I want to introduce you to our lab. Some of you I recognize, and I'm sure you know us, but our product performance testing lab at TCNA is the largest independent tile, stone, and installation materials testing laboratory in North America. We are an ISO 17025 accredited laboratory. Our headquarters are in Clemson University, hence why both Grant and I are from Clemson. And we have a partnership with Clemson, and we'll talk a little bit about some of that later. So currently, the staff in our lab has a combined work experience at TCNA of over a century. So we have a lot of technicians and engineers in our lab that have been there for a long time and have a lot of experience. We have 3 engineers, 1 PhD microbiologist, and 6 technicians and support staff. So the lab does confidential product and performance testing for really any materials related to the tile industry. So ceramic tile, glass tile, dimension stone, installation materials. But we also have gotten into testing other products, other flooring, wall covering, and countertop covering materials. We do over 70 ASTM, ANSI, and ISO standard test methods, and we also get into customized services for forensic testing, also just targeted research for our clients, product development, testing for development of new standards, and then really anything that's necessary. We obviously, you heard in our bios, we're very active in standards development. That's a big part of TCNA in general. So our staff participates on ANSI, ASTM, and ISO standards and numerous installation guidelines committees. We actually hold leadership roles in pretty much every one of those areas. So that provides unique knowledge about the standards that we're working with, and which really helps our clients to better understand not just how the test is done, but why it's done a certain way. So, new and evolving products often lead to new standards development, which leads to expansion of our lab. And so I'm going to talk through some of the new standards developments that have taken place that are now available, testing available in our lab. So hopefully this is all news to you. So TCNA is always expanding services. We have to meet the evolving needs of our industry, and as you know, there's always new things coming out in the industry. So we're we always get a kick out of those calls when somebody has a brand new product. There's not a standard that fits it, so we need to work with them to find a way to test it to make sure that it's going to work in the field. So as new products are developed, these old standards don't work, so new standards need to be created. So you'll see a few examples. And then, of course, we'll talk about our new life sciences research department for microbiology testing and other life sciences research. So here are a few examples. Recently, it was published in November of 2021, there's a new standard for self-leveling underlayments. Self-leveling underlayments have been around in the industry for quite a few years, but there's never been an industry product specification for the tile industry to be able to evaluate these products and differentiate between those that may not work well versus ones that are working fine. So this standard was developed by the ANSI ASC A108 committee. The standard has a name that just seems a little bit overwhelming, but this is part of the consensus process. So the product name is flowable hydraulic cement underlayment / self-leveling underlayments. So there's different naming scheme because of some of the concerns about whether or not these products are actually self-leveling. But the testing is now available in our lab for these products. So the standard includes various requirements for these standards, or for these products. Those include tests for flow, so initial flow, flow retention, healing time, which you can see on the bottom right corner of the screen. So we're setting it up and coming back every few minutes to see how long it lasts or how long it takes for it to heal. And then the set time of the material. There's also tensile bond strength and compressive strength, which is very similar to some of the other tests that we do for other products in this industry. Coming soon. So it's a standard that just passed or just was updated for criteria for porcelain pavers. It will be part of ANSI A137.3. The criteria is for 2 cm products. And that was, again, approved in our ASC A108 committee. So previously, this standard, it existed. You may be familiar with that for the gauged porcelain tile and panel slabs. That was for tiles that are 3.5 millimeter to 4.9 millimeter, and then 4.9 to 6.5 millimeter thick. So now there'll be a new chart, a new category in this standard for 2 cm tile or greater. So with the unconventional installation techniques, these new tests had to be developed to better understand the limitations of these products. So these are all installed, as many of you probably know, these are installed in different ways. So on pedestals or on grade installations, and aren't supported in the same way as typical adhered tiles. There's applications for pavers. Often they need to sustain heavier loads, so you need to test them differently than you would for a traditional thickness tile that's in just regular foot traffic. So testing these products for a different strength or in a variety of ways was very important for this standard. So TCNA did a lot of the research for the development of these criteria. So the key physical properties were impact resistance, which is a new test, and you can see one of this is the soft body impact test that was created in the standard, compressive strength, braking strength, and then a measurement of thickness variation. And so again, the lab is offering these tests. I'm going to go back and re-show you the videos again, just so you can see those one more time. So clearly, this is the importance of having a standard, because the first one, you saw how well it withstood the falling of that bag on there, which, Ryan, how heavy is the bag? 90 pounds. So this is important because you think about where these are installed, often on rooftop decks or on patios, and they're on raised pedestals, and if somebody were to fall, then that bottom one would be problematic. So this is why we needed standards. So speaking of porcelain, we've talked about PTCA for a long time. The Porcelain Tile Certification Agency is actually 15 years old later this year. So the PTCA program offers manufacturers and distributors a way to prove that their products are porcelain. So our lab is the only lab that does the testing. We're the only approved lab that can do this testing for the PTCA program. So new and expanded forensic testing services. So we talked about there's times where standards aren't really available. And really, there's not a set way to test things. And a lot of that comes in when there's an issue or a failure, and you need to do some forensic work. So our lab can offer that as well. We do a lot of this work with our partnership with Clemson University because they have a lot of analytical equipment available, and we have the capability of going to the labs at Clemson. We're right down the road, and using their equipment. This can be used for confirmation of product chemistry, analysis of failures, and detection of harmful substances in products. And included in some of that, the testing we do is SEM, scanning electron microscope, the GCMS, FTIR, ICP, and more. I know a lot of that. It's a lot of letters, but we are able to basically break down a product and tell you the chemistry of that material. So, also new, there's new standards for testing antibacterial activity on ceramic tile. So these are new ISO standards, but our PhD microbiologist, Dr. Ranganeni, was leading the effort in ISO to develop these standards that are specific for ceramic tile. There's two of them. One is the ISO 17721-1, which is for ceramic tile surfaces with incorporated antibacterial agents, and then 17721-2, which is for ceramic tile surfaces with incorporated photocatalytic antibacterial agents. So there's been a high demand and significant impact for the built community in the wake of COVID-19. What we've seen in our lab has been actually incredible, the increase of interest in this kind of work. So post-pandemic, you'll see that surfaces need to be resistant to microorganisms and easy to clean and sanitize, but while still maintaining aesthetic. So there have been many tests that existed for testing antimicrobial properties or antibacterial properties of surfaces, but all of those were for plastics and fabrics and other materials that just weren't the same as ceramic tile. So this standard was necessary to develop for the products of our industry. So all this work And the increase in microbiology testing that we've been doing for 10 years has led to the development of our new life sciences research department of our lab. We're going to offer increased services just because we see a need. There's not a lot of labs out there that can offer this kind of testing on surfaces. There's many labs that do microbiology, but not that have the expertise that we have in this field. So the testing and evaluation of products we can do antibacterial and antiviral properties. You can see the list of bacteria that we work with. I am not going to attempt to read the list there. You can see that. You can talk to Dr. Ranganeni after, and she can spat those off for you. I'm not going to try to read those. But we also work with viruses as well. Typically, they're surrogates of the actual virus, so we're not working with the live viruses in our lab, but that's typical for testing surfaces. So we've worked with SARS-CoV-2, which is related to COVID-19, adenoviruses, hepatitis, influenza, so a lot of those viruses that are pretty common. We test all kinds of materials for that. We're also looking into future opportunities for our lab in the life sciences research department. With the current capabilities we have, there are many other fields of research and testing that we could get into, such as testing food contact surfaces, which is important, especially with ceramic tile starting to be used more and more in countertops. Food product testing, that's actually testing of food products. Medical device testing, and many others. So we're excited to see where we can go with these capabilities that we have. So with that, I'm going to hand it over to Grant to talk to you about some of his work with slip resistance.
Thanks, Caitlin. As Caitlin just mentioned, and as John mentioned earlier, my name is Grant Davidson. Thank you all again for coming. My portion is going to be specifically dedicated to slip resistance and friction. We're going to talk a little bit about standards. We have some updates for you. You might have heard about this first one, but we have another update on the next slide that I'll touch on. And then after that, we'll address, kind of some of the science, the testing, what goes into all of this. So to start, the first standard I want to talk on is ANSI A326.3. I'm sure many of you have heard of it, but if you haven't, this standard is the American National Standard for measuring dynamic coefficient of friction, DCOF, of hard surface flooring. It was initially published in 2017, but now there was recently a new update published to the standard in February of this year. And for the first time ever, it's providing hard surface flooring manufacturers with a standardized criteria that will allow them to communicate product use. And so the way they're going to do that is the standard has a 5-category product use classification system. We'll talk about those in a second. The other update is to the ANSI A137 suite of standards, .1, .2, and .3, which apply to ceramic tile, glass tile, pretty much any procurement of ceramic tile in the US is going to be tied back to these standards. And what happened is the ANSI A108 committee, the Accredited Standards Committee A108, incorporated the A326.3 standard, the new version of it that was published this year, into those standards. Now, those are approved updates. They have not yet been published. We'll talk about that in a second. Let's talk about what these product use classifications actually are. So to meet the A326.3 standard, there's table number 1, which has the 5 classifications. And manufacturers need to classify their products into at least one of these 5 categories. They can kind of mix and match, but products need to be in at least one. They can be in more. Of the 5 classifications you can see here: interior dry, interior wet plus, exterior wet, and oils and greases. Each of those has a reference category. Those are kind of for manufacturers just to refer back to for ease of reference, or other users of the standard. And you can see the criteria here. Those of you who are familiar with the initially published 2017 version before it was updated might recognize the 0.42 value. That's kind of similar to what it already had in there, but now we've incorporated the A108 committee has incorporated manufacturer declared classifications. So what does that mean? Well, essentially that means that now manufacturers can classify into those categories that have the manufacturer declared criteria using any of the following. It can be their experience, it can be that DCOF test, it can be other test methods like the German ramp or the British pendulum, which we'll talk about those later. It can be the roughness, the surface profile, is the tile textured, is it treaded, any other slip resistance characteristics. As long as the manufacturer has that internally defined product selection criteria for the category, that's what they can use. And so each of these classifications, all 5 of them in the standard, which is available for free on TCNA's website, each of them provides descriptions and informative possible areas of use. These kind of give further perspective to any user of the standard on each of the categories and where they could potentially be used. So what role does the specifier play in all of this? As we all know, ultimately, it's going to be the responsibility of the specifier to make the project-specific selection. So, looking at the standard, just to give a few examples of what the specifier needs to consider when looking at these types of things, you'll want to look at type of use, traffic, how that floor is going to be maintained, what sort of wear is expected, and of course, the manufacturer's guidelines and recommendations are important. So, it is expected that reference of the A326.3 standard, the newly updated one, is going to result in better specification of hard surface flooring in the US. A326.3 is not just a ceramic tile standard. It's widely used in other hard surface flooring industries, but it is common to the ceramic tile industry. But as this is directly going to impact specifiers, starting with the manufacturers providing the classification and the specifiers using it, it's anticipated that this better specification is going to lead to potentially less slip and fall events than what's occurring right now. And so manufacturers have already started rolling out their product use classifications per the ANSI A326.3 standard, and with the expected publication of the A137.1 standards, .1, .2, and .3, that'll probably be coming this summer. It's expected that you're going to start seeing this more and more, and that these will be commonplace. So what's next? Of course, to meet the 137.1 standards, manufacturers will need to assign product use classifications. That hasn't happened yet. Those A137.1 standards still need to be published. They are approved by the committee, but they just need to be published, so that's coming soon. And that can be communicated pretty much at the manufacturer's choice. All that the standard requires is that it be communicated. It can be packaging, it can be product literature like a product brochure, or it can be a technical data sheet, a TDS, or it can be all 3. It's up to the manufacturer, just as long as they're providing it. And for distributors and importers or suppliers, you'll want to make sure that you're communicating with manufacturers. Talk to them, request and understand the information that they are using to make the basis for their classifications, and then work with your customers and make that information available to them. And speaking of customers, or just consumers in general, you'll want to talk to your sales representatives to look for products and make sure that you're using a product that has been classified for its intended application. And don't just limit yourselves to talking to the sales rep. Talk to the manufacturers, ask them questions, make sure you understand the classification, and make sure you're using it for the right application. So, those are the standards. Let's talk a little bit about the methodologies and what friction and slip resistance actually are, just kind of to get that background. So, slip resistance is a more overarching term, and one of the challenges that we see is people often use it interchangeably with friction or DCOF, but they're not the same thing. DCOF contributes to slip resistance, the more overarching term, which deals with all sorts of factors that affect the possibility of a slip occurring on a surface. And you can see this big long list of all of them, but really what it breaks down to is you'll have a human component and you'll have the more material component. The human component's going to deal with things like stride length, that person's gait, the physical and mental condition of the person at the time a slip might occur. And then the material component, which is going to deal more with the shoe outsole, the surface itself, how it's textured, are there liquids involved? Then you compare that to friction, which could also go on that same list because it's one of the many things. It's more on the material component of that side, but it's one of the many things that goes into the slip resistance that's experienced by pedestrians when walking on a given surface. It's actually defined in A326.3 as a force necessary to keep a surface in motion sliding over another surface divided by the weight of the sliding object. So it's more translated to somebody walking as opposed to standing still. Again, it's not the only factor in determining the appropriateness of a product for a particular application because decoff is not the same as slip resistance. They are related, but they are different. Decoff is very helpful in comparing surfaces, but it doesn't always predict the likelihood a person will or will not slip on a given surface. It is very helpful though, and that's why it's so widely used. But looking into this more, there's a lot of information out there. There's a lot of different terms. We've already addressed slip resistance and decoff, but then you add on traction, slipperiness, and it kind of muddies the water the way that people use them interchangeably. So decoff isn't always going to be enough. More guidance is needed from the foreign manufacturers. That's the tie-in to the requirement of product use classifications. There are also a lot of different testing devices out there. The testing devices, you'll typically hear them called tribometers. There are many available, but in pretty much every case, the results are going to be device specific, which is another challenge. So let's look at some of those. There are three kind of main categories that we're going to talk about. And number one, many of you might be familiar with it already because it's the most common in the United States. That's the drag sled style tribometer, which is usually going to be an automated machine that'll kind of drag a rubber slider across the surface and output either decoff or in some cases S-coff. And some of them can do both of that. There's also the pendulum tester. You'll hear this called the British pendulum pretty frequently. Results are represented differently from the drag sled. Those will be either British pendulum numbers or pendulum test values. And then lastly, we have the variable angle ramp. You'll hear this called the German ramp. It was developed in Germany and it's used there commonly. This is actually based on human ambulation, so it's different from the first two devices in that way. And the results are going to be represented as R values, and we'll talk about those more. So kind of breaking each of those three down just a little bit. As I mentioned, the drag sled is common in the US. It's the most widely used, and these will typically measure decoff. These are going to be, in most cases, lab and field testing capable. They're portable devices, and they can usually test in wet and dry conditions. The limitation to this is that measurements over, textured, profiled, treaded surfaces with kind of like a macro structure that might be intended to improve the slip resistance characteristics of a surface, sometimes it won't always be able to pick that up. And there's a lot of different models available. This is just one that I'm showing you. And results are always going to be device specific. It doesn't matter if they all say that the output is decoff. They're always going to be device specific. There might be some overlap from model to model, but at some point you'll encounter a surface, even if it might have been two models might have been comparable for several other surfaces. At some point you'll run into one where they measure differently. Next up is the pendulum tester, and we've actually got a video of it in action for you. This is going to be more typically used in the United Kingdom and Australia. It's used also in many other countries internationally, but those are the two big ones. It's not as common in the US. You'll see it here and there, and there actually is an ASTM standard E303, which does specify it. So in the US, you'll oftentimes see that standard referred to. And the advantages of this are similar to the drag sled style. It's lab and field testing capable, it's a portable device, and it can do wet and dry test conditions. Differently from the drag sled though, this one does have a rather stringent equipment setup, and it has calibration requirements. Again, with it not being as prevalently used in the United States, you might have more difficulties getting it calibrated. And then the test results are different. They're not DCOF. They're described as BPNs or PTVs, British pendulum number or pendulum test value. So that's different from DCOF. Next up is the variable angle ramp. As I mentioned earlier, initially developed and frequently used in Germany. There are various standards. One of the more common ones is the DIN 16165 standard, which is offered at TCNA's lab in addition to the other types of testers. And the advantages of this, the big advantage, is that this is actually based on human ambulation. And there are options for testing shod with shoes and barefoot testing. So this is going to be good as opposed to a drag sled where it might not be the best option for a heavily textured or profiled surface. This is going to be good for those types of surfaces because you actually have an operator walking over the test piece. And we'll show you the test in a second here on the next slide. But the limitations, you can see the device, it's huge. It is obviously not portable. So in situ testing, it just can't be done. It's a lab test, so you'll run into problems there. Sometimes after installation, if you look at commercial environments where you have lots of people walking over the floor, sometimes slip resistance or friction levels can change. So this would be unable to look at a floor that has been installed for 10 years that might have changed in its level of slip resistance over time. Also, the shoe testing is limited to an oil contaminant, and it's shoe specific. It's a specific work boot in the standard. And the interpretation of the results, which are R values, there are actually rather lengthy algebraic equations in the standards that you'll see for this that just make interpretation of the results not as straightforward as maybe a measured DCOF value. And so here's a video. Usually you'll have two operators. One will be walking up and down at a specific pace. It's usually around 144 beats per minute. So sometimes our lab techs will actually use a metronome, and you kind of walk at half steps down until a slip occurs while the ramp is coming up at a steady angle. And so tying it back to the A326.3 classifications, because that manufacturer declared criteria is now in there, a manufacturer could now choose to use any of those tests to define their criteria to declare a product for any of the manufacturer declared classifications. Only the first two, and optionally the second one can be manufacturer declared, but only the first two still kind of maintain that similar criteria to the previous version of the A326.3 standard. And of course, all of these are offered at TCNA's lab. We conduct all of these regularly. So just to recap, because I know that was a lot of information, from the standard side, the big takeaway is that there's a new version of ANSI A326.3. It's based on slip resistance characteristics. Manufacturers aren't necessarily now limited to just DCOF for the manufacturer declared categories. And ceramic tile manufacturers have already started making these available. And all of the three testing devices that we talked about, all of those options are going to be available at TCNA Lab. So my big two takeaways for this portion: the new A326.3 standard will lead to better specifications and potentially less slip and fall events. And remember, DCOF and slip resistance are not the same. So I'll hand it back to Caitlin to close us out.
Yeah, so obviously we discussed a lot today, but that just scratches the surface of what goes on in the lab and the different test methods we work with. We're happy to answer any questions you have about what we talked about today or something that maybe we've talked about before. And also, just before we get to questions, we are now on all social media, major social media channels, so please follow TCNA Lab for updates on our lab and things that we're working on. Does anybody have questions? Don't be shy. I see one in the back.
Caitlin, could you walk us through a hypothetical? Let's say you've got 1,000 square feet of 12 by 24 rectified porcelain, US porcelain, and it gets the job, and you're thinking you may have some warpage issues. So how does the process work? How much do you want to see tested, and how do you make the decision we're not going this higher, or it doesn't meet standards?
So there's two different things there. So the test method itself for warpage specifies at least 10 pieces. So that's at least a starting point. If you want to actually do a statistical sampling of the lot that you received, which is referenced in 137.1, it might increase from there because it's dependent on how many tiles, the square footage that's covered. So that can go from 10 up to 100, 150, 200 pieces. So then there is a chart in 137.1 for acceptance criteria. So once we sample the lot for warpage, then there's an acceptance criteria that says there can be this many pieces that are out of spec to be acceptable. So that's how you would determine that. John.
Is there testing available for some of the manufacturers that for antimicrobial sprays? Is there any type of test to verify that?
Absolutely. Yeah, we have done testing. Yeah. Yes. So we've done testing on disinfectant sprays, on coatings that are applied after installation or after manufacture. So absolutely, there are tests for that, and we can do them in our lab. Yeah. Any others? We're also going to be up here, so if you want to come and ask another question, go ahead.
Grant, you mentioned a number of different tribometers, like drag sleds that are on the market.
Yep.
I'm not familiar with any besides the bot that you guys would say is acceptable to be tested using this device. Could you point me towards another one, or is that the only one?
So when we look at the A through 26.3 standards specifically, what it actually calls out is the fine print. It's in a footnote. It says the BOT 3000E or equivalent. I'm sure you could find some tribometer manufacturers out there who are claiming their device to be equivalent, but as for what's specifically mentioned in the standard, most people are just going to go with the BOT 3000E right off the bat because that's what it actually says. So, I mean, I could rattle off a list of other different tribometers, but whether or not, the manufacturer's claiming equivalency to the BOT 3000E, which is called out in A through 26.3, that's a whole nother discussion.
I'll add to that. I think the important thing is, so the equivalence is claimed by the manufacturer of the equipment.
Right.
So if looking at results from another device other than the BOT 3000E that's referenced, it's important to ask that manufacturer, how did you determine equivalence? What data do you have to show equivalence? So it's possible there's others out there that are equivalent, but it's important to look at how that is determined. If it's just one test
Right.
here comparing two products, that doesn't really give you the full picture. So I think that's what's important, is to
Yeah,
look for
it's-
how that was determined in that claim.
And it can get a little tricky because, unfortunately, everything slip resistance is a work in progress. This is a consistently evolving field of study. But there, unfortunately, is no methodology laid out by ANSI, for example, to say, okay, here's what we need to do to say we're equivalent. And again, it ties into the challenge of device-specific results. So that's another big thing. I mean, you could have 2 different tribometer models, and you could have 10 surfaces, and it could measure, pretty much similarly on 9 of them. But then you get to the 10th, and one might measure up here, and one might measure down here. It's just how things work right now. So That's the big challenge with it.
Any other questions? If not, again, we'll be up here if anyone wants to come up and ask questions privately. And I have cards, and there's some flyers if you want to take those to find out more information about our lab. Thank you all for coming.
Thank you.